In this video, we'll make a quick review on stereoisomerism and optical isomerism. The definition of stereoisomerism: two or more compounds which are having same molecular formula but differ in spatial arrangement of atoms or groups and exhibit different physical and chemical properties. Those compounds are called as stereoisomers and the phenomenon is stereoisomerism. Consider these two examples. The arrangement of chlorine atom and bromine atom in this compound and chlorine atom and bromine atom in this compound are completely different. But the molecular formula remains the same if you notice. This is called as stereoisomerism. In short, molecular formula remains the same, but the arrangement of atoms differs. There are two types of stereoisomerism. One is geometrical isomerism and the other one optical isomerism. In your syllabus, you will mainly study about optical isomerism. Moving on to optical isomerism. What is optical isomerism? Compounds having same molecular formula and also the structural formula but differ in the direction of rotation of plane polarized light are called as optical isomers, and the phenomenon is optical isomerism. We'll understand this with example. Consider these two examples. When the plane polarized light is passed through this solution of plus 2 bromobutane, the light is rotated in the clockwise direction, whereas in this solution the light is rotated in anti-clockwise direction. Hence, these two compounds which have same names and same molecular formula are totally different because of optical isomerism. But what is this plus and minus in these two names? So, the plus and the minus are nothing but dextroisomers and levoisomers. What is dextroisomer? A compound which rotates plane polarized light in clockwise direction. Whereas levoisomer is that compound which rotates plane polarized light in anti-clockwise direction. So, the representation of plus is nothing but dextro compound and minus is nothing but levo compound. Hope optical isomerism is clear. Now, moving on to conditions of optical isomerism. The first point says the molecule should contain at least one chiral carbon atom. But what is chiral carbon atom? Chiral carbon atom is that carbon atom which has 4 different bonds attached to it. For example, this carbon is attached to one hydrogen, one bromine, one CH3 group and the last C2H5 group. So this carbon, which is represented by asterisk, is nothing but a chiral carbon atom. Hope chiral carbon atom is clear. The next point says the molecule should not possess plane of symmetry. What is not possessing a plane of symmetry? First of all, what is plane of symmetry? Let me erase this. Now, Consider this example. Carbon bonded to a carbon and rest of the groups. So, if you notice in this compound, there is bromine twice, hydrogen twice and CH3 twice. Consider another compound where two carbons are bonded and are bonded to different groups. So, when you compare these two compounds and draw a plane of symmetry or a line which intersects both the compounds in the middle, you can notice that in the first compound, the upper part of this compound is as same as the lower part of the compound. That is, this part is as same as this part. Now, by folding the compound in the middle, the compound overlaps. But when you observe the compound on the right, the upper part is not as same as the lower part. So, when you fold the compound at the middle, the compound do not overlap. So, the concept of plane of symmetry can be explained in the example on the left. Consider this example. Since by folding the compound at the center, the compound overlaps. Hence, the plane which cuts the compound is now called as plane of symmetry. So, this is the concept of plane of symmetry. So, remember the condition. The molecule should not possess the plane of symmetry. So, moving on to next concept. Racemic mixture. What is racemic mixture? The definition says equimolar mixture of D or L, which are nothing but dextro and levo isomers, is called as racemic mixture. Consider this example: plus 2-bromobutane, which is added to minus 2-bromobutane, where both are considered as 1 mole, which represents equimolarity or equimolar condition. This mixture is now called as racemic mixture, where equal moles of both dextro and levo isomers are mixed. The next point says the compound or the mixture is optically inactive. That is because when you consider dextro isomer or the plus isomer, which rotates the light clockwise, and the levo isomer, which rotates the light anti-clockwise, both the rotations get cancelled when they are mixed, and this is due to external compensation. Thus, racemic mixture is optically inactive due to external compensation. So, these two are the main points about racemic mixture. Moving on to the next concept. Enantiomers. What are enantiomers? These are optically active isomers which are non-superimposable mirror images of each other. What does this mean? Consider these two examples. The compound on the left and the compound on the right are the mirror images. The mirror is placed in the middle. Both contain chiral carbon atom. The left compound has 4 different bonds and the right compound has 4 different bonds around the carbons. And this is the mirror in the middle. Now, trying to superimpose the compound on the right on the compound which is on the left side. When this is superimposed, both the compounds do not get superimposed, and that is because the bromine atom does not superimpose on the hydrogen, and also the hydrogen atom does not superimpose on the bromine atom. Hence, both the compounds are not superimposed. Hence, the definition of enantiomers say the optically active isomer which are non-superimposable mirror images of each other. Hope the concept of enantiomer is clear. Moving on to the next concept. Mesocompounds. What are mesocompounds? These are the organic compounds which have more than one chiral carbon atom but are optically inactive due to plane of symmetry. That is, when you consider this example, the compound contains 2 chiral carbon atoms. The first chiral carbon atom has 4 different bonds. And the next chiral carbon contains 4 different bonds as well. Even though there is 2 chiral carbon atoms, the compound is optically inactive, and you know the reason already, because of the plane of symmetry. When this compound is folded in the middle, the compound superimposes or overlaps. Hence, these type of compounds are called as mesocompounds. This is plane of symmetry. And due to this plane of symmetry, the whole compound is optically inactive. I hope the concept of enantiomers and mesocompounds are clear. That's it for the video. Thank you for watching.